All right. Well, my custodian buddy kind of came in and interrupted that video, and I certainly didn't want to start over. So I just chopped out the part where we were talking, and we're finishing up the last video and going into the next one. Okay, so anyway, let's finish up that last part of that first problem, part C. That was a long one here, so I wrote it out because I didn't want you to have to actually watch me all doing that. Takes a while. So we got you in the picture. This is actually acetic acid. You'll learn that, very important, weak acid in solution. This is methanol. I said ethanol, that's ethanol, that's not methanol. Methanol is a bad stuff, that's ethanol, that's a good stuff. Good stuff. That's ethanol, this is ethyl acetate and water. Now what we have here is aqueous, and liquid. Remember? No liquid. So we're not putting that in our equilibrium expression. So the K is going to be a Kc. And I'm not going to write this whole thing out. You can do this. There are no coefficients, so therefore no exponents. Just take your ethyl acetate, put that on top, put it in square bracket, put that over. Okay, so put that over the ethanol and put that over the acetic acid in brackets. You doing this? And make sure you're multiplying. Doesn't matter which one you put first. Doesn't matter. Okay, you got that? No exponents on any of them because there are no coefficients. Okay, that would wrap up that last problem. Wanted to get that all in, but Steve the janitor, he's the guy who plays the Metallica stuff in the background. Well, it's some hard rock station. Could be Metallica, could be anything. All right, here we go. So that is the idea behind equilibrium and how to write an equilibrium expression. But the thing is, what does this K value mean? And I want my students to understand the chemistry that we're doing and how it applies. So if you looked at your sheet, where is it? There it is. Okay, what does K tell us? All right, let me give you a generic example here. Got compound A and compound B in equilibrium. Arrow both ways means equilibrium with C and D. Okay? Now, if we were to have the actual concentrations of all these and write out our K value, and let's see, there's a Kc, so we'd go concentration of C, concentration of D, over concentration of A, concentration of B. And we were to put the numbers in, which we'll be doing very soon. Put the numbers in, calculate it, get a number. Get a value for K. So what? Got it. All right, I got it. I got what the answer says on the sheet. Yeah, you did it. Yay, me. What does it mean? I don't know. You tell me. Okay. The K value means, or it indicates which way the direction likes to proceed, or in other words, which I'm going to say that. I shouldn't say that. Back the truck up on that. Beep 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 beep. Not which way it likes to proceed. Sometimes it does. Those are actually called Q values, which are close to K values, but I'm confusing you now, so I apologize. Forget the last 20 seconds. It tells you which are favored, reactants or products. Well, what does that mean? Which are favored? Which ones you're going to have more of? That's what the K value tells you. Now, remember I use Walmart as my example. You can have equilibrium, people going in and out of Walmart equally, but there are a lot more people outside of Walmart than there are inside of Walmart. So if the reactants are the people outside of Walmart and the products are the people inside of Walmart, outside of Walmart is favored. There are more of them than people in Walmart. So when we say favored, the products are favored. That means there are more products than there are reactants. If we say the reactants are favored, there are more reactants than products. All right, and the K value is also going to be very important, not only to tell you what side is favored, but which direction the reaction really likes to go. So, I mean, most of the time don't want to go into Walmart. Sometimes you do, most of the time you don't. Most of the time you don't want to go into Walmart. You want to be outside of Walmart, enjoying the nice, hot, sunny day. Okay, so just because, so if I give you a number for a K, you should be able to tell me whether or not people want to go in or out of Walmart And what's favored? People in Walmart, people out Walmart. Maybe sometimes it's, super good sale going on. Everybody in the entire town of Hooksett wants to be in Walmart, and there's more people in Walmart than outside of Walmart. It'd be kind of weird. You know where to go. Couldn't move. Okay, so these K values mean something. We are going to look at K's values compared to the number 1. If a K value is greater than 1, or if a K value is less than 1. If K values are greater than 1, the products are favored. In other words, the reaction really, 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 really likes to proceed from left to right. If the K value is less than 1, so we'll put down here K value is greater than 1, products favored. The reaction wants to go really badly to the right. If the K value is less than 1, the reactants are favored. That means the reaction really, 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 really likes to proceed to the left. So now let me give you an actual equation for this, and maybe this will help clear it up. Water. You can take 2 hydrogens and an oxygen, put them together, you get water. And that is a balanced reaction for water. Hydrogen and oxygen really, 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 really want to make water. Water really, 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 really does not want to break down and form hydrogen and oxygen. You can do it. I remember in 8th grade physical science class we did that. We broke water down. We had to use electrolysis. We had to put a lot of energy into it, electrical energy into the water in order to create hydrogen and oxygen gas. You can do it, but it doesn't want to do that. When given the chance, that hydrogen and oxygen are going to go back together, go, whew, water. So this reaction would have a K value much, much greater than 1. It's really big. In fact, we will do that, and you'll see how big that is. The K value means if it's greater than 1, and it would be for this direction, it would be there's going to be a lot more water around than there is hydrogen and oxygen. Is it true that some of the water will break down to form hydrogen and oxygen? Yeah, it is, because you can see this goes in both directions. And that means that, we have at equilibrium, we would have these forming that breaking down and forming this. There would be a crap ton more of this around than there would that. So K's are going to indicate which direction the reaction wants to go. If we wrote this reaction backwards, well, I won't say backwards, I'll just say in the reverse direction. Backwards makes it sound like it's not supposed to do that. We can do this. I mean, you can get water to do this. You would usually see electrolysis here to indicate that that's what's happening to get this to go this way. I mean, usually we always wrote the water reaction just like that. And that's why we write it. So, because up to now, this was exactly what happens the vast, vast majority of the time, and most of this does happen, but it does go back the other way. So now, we're in advanced chemistry. We have to realize it goes in both directions. If we were to look at the K value for this reaction, that K value would be really, 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 really small. It's really small, depending on the temperatures and pressures and stuff. Yeah, we'll do 2 calculations with that. It ends up being like -31 and like -84 in one of those reactions, if I recall correctly, in the ones I put into the problem set. So that's really, -84 is really small. That means that this does not want to do that. It will rarely, but doesn't want to. You're going to have a lot more of this. All right, so I'll keep coming back to this. I'll remind you of what these K values mean. They don't go away. They are actually all the way through the class to the very last day. The last day we do electrochemistry, and electrochemistry has to use, in times, K values. Okay. So that's what the K value means. I'll go back to it again and again and again. All right, okay, let's do a problem. Actually, you know what? We'll stop this video. We'll keep this video short. We'll call it the continuation of that last problem. And what does a k value mean? All right.